Well, Mr. Kasparov, thank you so much for joining us and spending the morning. And it's just going to be a short discussion. Going back to 1997, your match with Deep Blue. Of course, it was, everyone tends to talk about the second match, but I just really love to understand what was your mindset at the time, and how has it evolved in the last almost 30 years?
Yeah, thank you for reminding our audience that it was a second match, rematch, because I won the first one, 1996 in Philadelphia. But the history of human machine competition, in chess started early. Of course, for a long time, machines were not just a good match to top players. But in 1989, I had a first experience playing Deep Thought, which was a prototype that later became Deep Blue. It was developed by the young scientists in Carnegie Mellon University and later purchased by IBM, the whole project, and turned into this. It's a mega project of parallel processors that, as one of the sub-products, had Deep Blue.
Right.
Deep Blue was not a chess playing, just a machine only. It was a part of this parallel processors, which was pretty successful project itself. In 1989, I won handily, but since the beginning of the 90s, many chess players already experienced some problems with chess engines. Because we have some strong chess engines, the German program Fritz, one of the first, in the field. And in 1994, we played World Blitz Championship, which is 5 minutes chess, Intel Blitz Championship. And I won the event, but we tied with Fritz.
Right.
So and then I won the tie-break match. But the fact is that, it was a tie, and the machine did so well against the best players in Blitz. That was already the first signal. And then we played rapid chess, 25 minutes chess, and also many of us, myself included, suffered some painful defeats in occasionally. But we were under impression, totally wrong, of course, that if we add more time, we would have more time just to avoid any blunders, to control the flow of the game, ignoring the simple fact we have more time, machine has more time.
Right.
So the 1996 match that I won in Philadelphia was, probably was a watershed moment, because while I won the match, I lost game one in the match. So this is it was 6 games match. I lost game one, then I won game 2 and game 5 and game 6. So winning 4-2 with 2 draws in the middle. But the fact is that machine could beat the sitting world champion in what we call classical chess, 6 hours plus.
Yeah.
That was already like a sign on the wall, with capital letters.
Right.
It's coming.
Right.
So the 1997 match somehow, just was a shock for general public. But analyzing now, just 28 years later, so the outcome, actually 30 years of this, of these relations, humans and machines, and also knowing that by 2005 the competition was literally over. We still could compete. The 97 match was not, was not the end of the story. It took another 8 years before machines totally dominated the field. I actually played in 2003 2 more matches against older version of Deep Fritz and then the Israeli program Junior. Both ended as a tie. But I knew back in 97, 98, day was coming.
Right.
So that's why it was already a moment for me to recognize that end of the competition. So stop competing, start collaborating, start looking for the best ways to bring together machines, brute force, and pattern recognition to humans' creativity and intuition. And that's how I came up with the idea of advanced chess: human plus machine versus another human plus machine.
Right. The Kasparov law.
Kasparov law is just, came up later because we found out by making experiments, by playing online. So it's in this competition, advanced chess, human plus machine versus another human, or groups of humans, or plus machine, or groups of machines. So the decisions, the quality of decision and the outcome depends not only on the quality of a human player, not even just talent, not on the speed of the machine, but on the synergy, on the superior process. So weaker player with slower machine could beat a stronger player with a faster machine if he or she will have better collaboration. Because at the end of the day, it's about finding the best formula that will increase the output.
Right. and how would you think that, so the process itself, how would you thinking about chess at the time, and you had the foresight to think about this collaboration outperforming the, so how did you see the future in collaboration in chess?
Look, chess has changed dramatically because it's today, we all know that even Magnus Carlsen, the strongest player, he's no match for a computer.
He
Okay,
would probably lose to it a game or
maybe he could compete, maybe, but
right,
but it's still it's unlikely.
correct,
But when you look at the chess engine at your laptop, so the difference between this, chess player, Silicon chess player, and
right,
Magnus Carlsen is about the same as between Usain Bolt and Ferrari.
right,
The first 50 meters they run, just on par. Then it's over.
right,
So but machines played a very important role in changing our professional preparation.
right,
Because when you look at the games today, many of the traditional openings that have been played when I was active, they have gone because you don't want to take the risk. Because it's not about just trying to prepare some very sharp lines where this slight sleep or just not recognizing what can be done by the opponents who has a machine and is more agile in using the computer. So you can be dead just without just making a single move in a real game. It was all could be decided by the machine's preparation. So
right,
it's very logical that top players they avoid very sharp lines. We had few interesting duels 5-6 years ago. What just but it became very apparent that it's too risky
right,
because it's preparation basically decides everything. So they shifted to more like we call positional chess. So when the main battle is pushed from the opening to the middle game. So
right,
what just you can slow develop your pieces and create situation where machine preparation is not going to solve everything. And yeah, some people are just complaining, saying, "Look, it's not the same excitement when Kasparov played Karpov. So we just had all this fun." But I can see as it's the positive side because with machines we always have both negatives and positives. And
right,
yes, somehow it's a bit odd for me, just as a former world chess champion, to see that my colleagues, just playing the game, and you can see on the screen that they're not doing the best moves. And every amateur on the planet now can see that
right,
Magnus Carlsen is not playing as well as machine recommends.
right,
But the fact is that you can have now millions of people watching the game without, waiting for a special commentator for a grandmaster,
right,
basically having an understanding. That's a big win for chess.
huge, yeah,
It's computers, yeah, they somehow downgraded the glory of the top players in the eyes of the beholden.
right,
But on the other side, they brought millions into the game because now you can follow, because and you can see instantly whether Magnus or just another top player is doing well or not. So you are engaged. So you don't have a special preparation or just the special commentary to follow the match.
yeah. I think I love your framing that the ideal engine, because it's a finite number of moves, regardless of how big it is. The machine, the engine, the person who makes less mistakes will eventually.
But you said finite number of moves. Okay, technically any number
Correct. Yeah.
is a finite number. So, but this number of legal moves in the game of chess contains 46 zeros according to Claude Shannon.
Right.
I don't think we can call it the number that makes any sense to us.
Of
So
course.
yeah, it's finite on paper,
Right.
but for us it's not something that could have any practical, even in the remote future, practical implications.
Right.
Because in chess we have now all positions with seven pieces
Yeah.
positions being resolved. It's the database. I think it's over 100 terabytes. But that's seven pieces.
Right. Yeah.
Just seven pieces.
Right.
Now imagine that this is the game with ultimate end game with 32 pieces. I don't think we ever crossed to 8. because it's
Exponential.
oh, exponential, just beyond our. It's even with all the powers we have. So again, it's chess tells you that the future of this collaboration, recognizing that you don't expect machine to solve all the problems.
Right.
You expect machine to make fewer mistakes, to limit your mistakes, and also to offer you immense power. But that's for you how to guide this power. This is the biggest advantage that we may have, is that it's to or competitive advantage. If you know how to harness this power, imagine you have a tsunami.
Right.
And you can just change it a little bit. So that's and it will the destruction it brings, will change. So here is just, you have this immense power, and slightly shifting it, just it's like a bullet in the barrel of a very powerful rifle. So could have a tremendous outcome when this bullet hit the target 2 miles away. So again, recognizing that we do belong to last few decimal places. Machines can do 95% of tasks better than us. Recognize that. That's key. Psychologically, don't compete with machines where, we already inferior.
Right.
And find the area where human contribution for this specific task could be absolutely unique. That's where you have your competitive advantage. Because again, this is so many areas where there's the machines' immense power could do a lot of good, providing it has a proper guidance.
Proper the process that you.
Probably again, it's about superior process. It's about recognizing where your human creativity, your human intuition, your human experience could help machine.
Yes.
To again, not to compete with its recommendation, but basically slightly shifting in the direction you wanted to go.
Correct, which is immense power by itself.
It's right, yeah, absolutely. This is recognizing that it's again slightest tweak,
Right.
could have a tremendous result. And again, it's I would say it's a very creative process, because yes, we have similar machines, we have similar tasks, but they all not the same. And by the way, we also different. So this is again recognizing, what kind of contribution I can make for this task, and also at what point I want to get in. This is again even timing.
Right.
Could mean everything, because it's so easy just to be mesmerized by the computer. You look at the screen, data coming. Yeah. Stop. The moment you stop and and say, okay, now I push the button. Just imagine the difference.
Right.
Even if you do it, 2 seconds later or 2 seconds earlier, that could just have tremendous implications. Again, the human contribution, no matter how small, could still be a decisive factor in a very competing field, whether it's insurance or any other area where AI has been playing already a major role.
Yeah, I couldn't agree more. I think it's the applicability to insurance. It's so easy for executives, I find, to really buy into the hype, trying to find the solution that solves all problems. Whereas I agree with you that the foundation may be flawed if you're not thinking about the process. So on that note, and I know we're coming about time, but what would be your suggestion to these executives to implement these models accordingly, so that their really focus remains on the process itself, not so much on solving everything?
Oh, again, every industry has its own problems and challenges, and obviously the solutions, creative solutions coming from AI or AI collaboration with experienced humans, differs. But specifically in insurance, I think that's one of the interesting challenges will be how to adjust your rates to the change in probabilities. For instance, in car insurance, if you have driverless cars, the moment you have enough driverless cars on the road that are being programmed specifically, let's say the life of a passenger is number one priority. Right. So you will see the change in probabilities of the outcomes of the accidents. So this is it's an amazing challenge. Yeah. But if you recognize it's earlier than others, right, again, you'll see, okay, enough cars on the road for me to start offering this new packages. Right. So that's an advantage. Right. And again, it's not something that you can find in the books. You basically have to create books, because you're talking about immense probabilities. But again, it's all statistics as insurance, because right, you work with probabilities. And right, now this is recognizing when it changes, and it's quite dramatically changes, because again, It's uncertainty that it always follows accidents on the road will be dramatically reduced because you already may know not 100%, but you could be quite confident about the outcome because machines will be programmed to a certain way, and maybe the owner will have a choice how to program it. But again, great new challenge, virtually unlimited field of possibilities, and here you need a most effective collaboration between human expert and AI.
Right.
So it's a key. It's if you try to rely on computers, you're on the losing side. If you downplay the role of the computers, you're on the losing side. So you have to find the most effective collaboration between human and computers to constantly adjust your, in case of insurance, your rates to be just to be ahead of the curve.
Right. It's giving that tsunami a direction to go.
Absolutely.
Right. So building that premise so that you can use the machines to fill in the blanks. I recognize we're at time. I really appreciate you taking the time. It's an honor to speak with you, and thank you again.
Thank you. Thank you for having me.
Thank you.